Hello, ladies and gentlemen. Today we're going to look at rotations. A rotation is a transformation that moves every point of the preimage through a specified angle, x degrees, and direction, either clockwise or counterclockwise, generally counterclockwise, about a fixed point called the center of rotation. If the point being rotated is the center of rotation, then its image and preimage are the same point. If the point being rotated is not the center of rotation, then the image and preimage are the same distance from the center of rotation. And the measure of the angle of rotation formed by the preimage, center of rotation, and the image point is x degrees. All right. Now, you can read this sample problem. I'll let you do that on your own. I'm going to go ahead and start rotating some figures. All right, we'll start with number one. We're going to rotate this quadrilateral RSTQ, or QRST, however you wish to name it, 75 degrees. Now, please remember that 75 degrees is always going to be, anytime you see a degree, it's considered to be counterclockwise. Okay. So what I'm going to do is I'm going to draw, first of all, I'm going to rotate, decide which point to rotate. I'm going to rotate the closest point to the center K, all right, which is point S. So I'm going to draw a ray from K, the center of rotation, through the vertex S, all right? And that should be that ray right there. Okay. And now I'm going to place that ray on the right-hand zero of my protractor, okay? And I'm going to measure, come from the inside, 75 degrees, which would be up in here, okay? And then I'm going to come through here, okay? And I'm going to measure out that distance and make another ray. All right, now, I have to measure KS because S prime is going to be out that ray KS units. So I'm going to go and measure, and I will measure with my compass KS, and when I measure out KS units out through that ray, all right, that point right there will be point S prime. Okay. Next, I'm going to rotate point point R. K is the center of rotation. We're going to rotate point R. So I'm going to draw a ray from the center of rotation through the second vertex that I'm going to rotate, and it's okay if you draw it big, long, it probably works easier that way. All right. And now I'm going to measure off of that ray, counterclockwise, 75 degrees. Okay. And I'll line up K with that 75 degree mark. All right. And somewhere out that ray will be point R prime. And the way I locate it is to measure KR, because R prime will be KR units out that ray. All right, so I measure KR. All right, when I do, I see that point R prime is that point right there. So there's point R prime. All right, I'm now going to rotate point Q. So I'll draw a ray KQ. Far across there as I can. Okay, I'm going to rotate that so that it's pointing to the right. I'm going to come and measure off, going once again. 75 would be approximately right there. That's about the best I can do. So I'm going to draw a ray from K through that point. All right, 75 degrees. And somewhere out that ray will be point Q prime. And the way I figure out where out there it is I measure KQ, that distance right there. And you can use a ruler if you want, that's okay. I can't do the rulers, my vision is not all that well. So I'll just put that point right there, and that will be point Q prime. All right, and I believe I need one more point. That's point T. All right, so I'm going to draw ray KT. All right, I'm going to rotate it so that ray KT is to the right, horizontally, as best as possible. And then I'm going to measure 75 degrees, which would be approximately right there. All right, and I'm going to line that up with the center of rotation and draw ray K T prime. Okay, and now I'm going to locate T prime by measuring KT. All right, that's that distance. And that means that point T prime will be this point right here. There is point T prime. So then I can connect R prime to S prime. And you can start at any of these vertices. It really wouldn't matter. R prime to S prime to T prime to Q prime back to R prime. And I have rotated what looks like a rectangle 75 degrees. Okay. All right. Next, we're going to go to number 2. We're going to rotate triangle FGH about point K. All right. And what I'll do is I'll start with point H first. So I'm going to draw a ray from the center of rotation through that first vertex. And then I'm going to come and measure off of that ray KH, I'm going to measure 45 degrees. Okay, 45 degrees would be about right there. Okay, so somewhere out through here is point H prime. All right, and the way I locate where exactly out there it is I measure HK or KH. It's the same thing, either way you want to think of it. All right, and then I come from K, that distance out that ray. All right, and there is point, H prime. I've rotated point H 45 degrees. Now I'm going to rotate point F 45 degrees. So I draw a ray from the center of the rotation through the vertex I'm rotating. All right, I'm going to point it to the right so I can measure my 45 degree angle. There's 40, 45 would be about right there. And then I draw a ray that will contain point F prime. So somewhere out that ray is point F prime. And the way I locate how far out there to go is I measure the distance from the center of rotation to point F, or measure KF. And then I mark out KF units out from there. Okay. And now I have located point F prime. All right, next I'm going to rotate the third and final point, point G. All right, so I'm going to draw ray K, G. All right, I'm going to point it to the right, and I'm going to go over here and measure 45 degrees. 45 is approximately right there. All right, so I'm going to draw that ray. All right, and somewhere out that ray is point G prime, and the way I locate it is I measure the distance from the center of rotation K over to G, or from G to K. It's the same distance either way you want to measure it. All right, and then when I come and measure that, mark that off out that ray, I then know where point G prime is. This point right here is point G prime. And once I get all three vertices rotated, I can connect G prime to F prime, F prime to H prime, all right, and then G prime to H prime. And there is that triangle rotated 45 degrees. Okay, now I'm going to go do number 3. We're going to rotate 135 degrees. Okay, all right, and I like to rotate the closest point to my center of rotation first. So I'm going to rotate point B first, if that's okay with you. All right, so I'm going to draw a ray. I'm going to draw ray KB. Okay, and I'm going to point it to the right, and then I'm going to measure, what are we measuring? 135 degrees, okay? Now, here's something that might help you. If you run out of space, like 135 degrees is up here, and I've run out of space, so I've I knew that might happen, so I brought some extra paper with me and slid it up under my paper. As you can see, my paper right here, well, that'll give you, and then if you hold them down, that'll give you a little extra room. All right, so I've got to measure 135 degrees. So I'm going to measure not 90, 135 degrees would be over here. Okay, now hold that paper down tight when you move things. All right, and then draw your ray from here out as far as you can. Okay, so somewhere out that ray is point B. And the way I locate point B is I measure KB. Okay, so I measure KB. Okay, and then I mark KB units out that ray to locate B prime. All right, so now I have located point B prime. Okay, all right, so there's point B prime. All right, now I'm going to rotate point C next, okay? So I'm going to draw ray KC, because C's close, all right? So ray KC is here. I'm going to rotate that to the right, pointing to the right, so I can measure 135 degrees. Okay, 135 is right there. Hold that paper down because I needed that extra room out there. And then I'm going to line that up. And somewhere out this ray right here is point C prime. And the way I locate C prime is I measure KC or CK, same difference either way. All right, and I mark out that distance out there. So there is point C prime, okay? All right, now I'm going to rotate. So I did B, C, I'm gonna go ahead and do D. All right, so I'm gonna rotate point D. So I draw ray KD. Okay, all right. Move it to the right so I can measure 135 degrees. 135 degrees, so don't let it slide on me, okay, is approximately right there. Hold the paper down so it doesn't move. Line up point K with that 135 degree marking and draw your ray out through there. All right, and now I'm going to measure KD. All right, so KD is that distance right there, okay? All right, and that will allow me to locate point D prime. There is point D prime. All right, and now I'm going to rotate the fourth and final vertex of this quadrilateral, point A. So I'm going to draw ray KA. And you can make that thing go long. I don't care if it goes into some other work. That's not what's important. What is important is that you're able to measure it and be precise with it as much as possible. Okay, so we're going to go not 91 but 135, which would be approximately right there. So we'll line up K in that 135 degree mark. Okay, and out that ray will be point A prime. Okay. All right, and the way we locate how far out there to go is to measure KA. Okay, all right, there's KA, and then we go down and we mark it off. Okay, so now we have located point A prime. And now you can connect A prime to B prime, B prime to C prime, C prime to D prime, and then D prime back to A prime. And voila, you have rotated a quadrilateral A, B, C, D, and gotten quadrilateral A prime, B prime, C prime, D prime. Okay, and that's rotating without a coordinate plane, ladies and gentlemen. Next, we're going to look at rotating on the coordinate plane. All right, so let's turn the page on our notes. And here are the rules for rotating 90 degrees, 180 degrees, 270 degrees. All right, the procedure or the rule for rotating 90 degrees is to multiply the y coordinate by -1 and then interchange the x and y coordinates. Okay, So that means that xy, and this is the coordinate rule, and this is what you need to memorize, okay, will become negative y comma x, all right? To rotate 180 degrees on the coordinate plane, all right, you can multiply the x and y coordinates by negative 1. So in other words, xy will change or transform to negative x, negative y, all right? And to rotate 270 degrees, you multiply the x coordinate by negative 1 and then interchange the x coordinates with the y coordinate, okay? So that means x, y, any ordered pair, would change to y negative x. Okay. Now, please be aware that 270-degree rotation clock, I'll always go counterclockwise when they're positive. That is equivalent to a negative 90-degree rotation. All right, 180 degrees is the same thing as a negative 180 degrees as well. 90 degrees is the same thing as negative 270 degrees. So there's many ways you can change these and make compositions of these, all right? Now, let's go down and do these exercises down below. I'll let you look at that first example on your own. All right, let's do example number 4 next. And the instructions say graph each figure and its image after the specified rotation about the origin. Now, all of our rotations that we're going to be doing in this class are always about the origin, okay? All right, so I'm going to first, with my pencil, plot the original because it said each figure, all right? And we have a trapezoid. F has coordinates of 7, 2, 4, 6, 7 would be approximately in the center of that box right there. There is point F. All right, G is located at 9, 2. I believe that point right there would be point G, 9, 2. H is at 3, 2. So that would be point H. All right. I is at 5, 2, 4, 6, 7. So there is point I. Now, I could not draw a straight line segment if my life depended on it without a straight edge, so I'll use my straight edge. I'll draw segment IH, segment HG, segment HF, and then finally segment IF. Okay, so there's quadrilateral FGHI. Okay, all right. Now, we are next going to rotate it 90 degrees. Well, I would write the rule down immediately. The rule says the XY changes to, all right, and that's this rule right here, 90-degree rotation, negative YX. Negative Y or the opposite of Y, whichever way you like to read it. I'll read it the opposite of Y every time, so keep that in mind. All right, so we're going to go and write the coordinates for each of these rotated vertices. Let's start with vertex F and find the coordinates of F prime. We want the opposite of this Y coordinate. The opposite of 7 is negative 7. And then we want the X coordinate, which in this case is 7, to become the Y coordinate. So F prime has coordinates of negative 7, 7. All right, G prime. All right, we go to point G. We get the opposite of the Y coordinate. The opposite of that 2 is negative 2, and that will be your X coordinate. All right, and the X coordinate will become your Y coordinate, so negative 2, 9 are the coordinates for point G. Next, or not G, but G prime, excuse me. All right, let's go find the coordinates for point H prime. So the opposite of the Y, negative 2, will become the X coordinate, and the X coordinate 3 will become the Y coordinate. We have one more point, and that would be point I prime. All right, so we go to I, we find the Y coordinate, take its opposite. The opposite of 7 is negative 7. That becomes the X coordinate, or here. And then the X coordinate of I becomes the Y coordinate of I prime. So negative 7, 5. And once you identify those four vertices, you can plot them. I'll do that right now. Negative 7, 2, 4, 6, 7 would be approximately right there. So there is the coordinates for point F prime. Okay, all right. G prime is negative 2, and then 8, 9 would be approximately right there. That would be the point G prime, all right? H prime is negative 2, 3, which would be right there. There's G prime. And then I prime would be negative 7, 5. So negative 7, 2, 4, 5 would be right there. Okay, and that would be I prime. And then you could connect F prime to G prime. All right, G prime to H prime. Whoops, hold on, I got two. Negative 2, 3. This one should have been H prime. My fault. I knew something was adding up here. Okay, all right. And then H prime to I prime. And then I prime back to F prime. And there you have rotated the trapezoid FGHI 90 degrees about the origin. All right, let's go to number 5. In number 5, we're going to rotate triangle LMN 90 degrees, okay? All right, well, let me plot the original first, if that's okay with you. So negative 1 would be in the center of that box right there. So there's point L, okay? All right. Now, let's 0, negative 4. That's this point right here. There's point M, okay? And then negative 6, negative 2 is point N. Okay, so I'm going to draw that triangle. Okay, there's that triangle. And now I'm going to use the rule for the 90-degree rotation, all right, which says that XY changes, once again, for 90 degrees. The rule is negative Y, X, okay? And then I'm going to say, okay, I'm going to locate the coordinates for L prime, M prime, and for N prime, all right? And first we'll do L. So we take the opposite of this y coordinate, which would be positive 1, and that becomes the x coordinate. This x coordinate, negative 1, becomes the y coordinate. All right, let's go get the coordinates for point M prime. The opposite of this x coordinate is positive 4, and the x coordinate becomes the y coordinate. The opposite of that y coordinate is, for N, is positive 2, and negative 6 becomes the y coordinate. So there are your coordinates for L prime, M prime, and N prime. I'm now going to plot those points, okay? So 1, negative 1, ooh, that's right in the center of that box right there, is L prime, okay? All right, 4, 0 are the coordinates for point M prime, and 2, negative 2, 4, 6 are the coordinates for point N prime. And then we can connect those, all right, in either clockwise or counterclockwise order. It really doesn't matter. And there is triangle L prime, M prime, N prime, which is triangle LMN rotated 90 degrees about the origin. All right, let's go look at number 6. In number 6, we're given triangle ABC with vertices A, negative 3, 5, B, 0, 2, and C, negative 5, 1. And we're going to rotate triangle ABC 180 degrees. Okay, well, let me go ahead and plot it first. So negative 3, positive 4, 5 would put A right there. Okay, so there's point A. 0, 2 is point B. All right, so there's point B. And negative 5, positive 1 would be in the center of that box for point C. All right, and I'm going to use my straight edge to draw these segments. Okay, there's segment AB, there's segment AC, and then I need segment BC, and I will have that triangle ABC graphed right there. Now I'm going to use my rule for the 180-degree rotation. The rule for 180-degree rotation says that XY changes to negative x, negative y, okay? Negative x, negative y. All right, so I want to find the coordinates for A prime, all right, for B prime, and for C prime. So I go to A, and I just multiply both by negative 1, so or change the sign, that's equivalent. So 3, negative 5 will be the coordinates for A prime. Well, if you multiply 0 by negative 1, you get 0. And if you multiply 2 by negative 1, you get negative 2. So 0, negative 2 will be the coordinates for B prime. If we go to C, multiply its x coordinate by negative 1, you get positive 5. And multiply its y coordinate by negative 1 gives you negative 1. And then I'll just plot those points. 3, negative 2, 4, 5 is in the center of that box right there. That is point A prime. Okay, 0, -2 is that point right there. That will be point B prime. And then 5, -1 will be in the center of that one. That will be point C prime. And then I can connect C prime to A prime to B prime, and B prime to C prime, and I will have that triangle rotated 180 degrees. And by the way, if you were to rotate your paper 180 degrees, you can see it's the same graph that would be there, except the name of the points would be upside down. Okay? All right. Let's go to number 7. All right, first thing we have a parallelogram, PQRS, with vertices P being 4, 7, Q being 6, 6, R having coordinates 3, -2, and S having coordinates of 1, -1. We want to rotate 270 degrees. Well, let me just plot it first of all. 4, 2, 4, 6, 7 would put point P right there. Okay. All right, 6, 6, so 6, 6 would be that point right there. There's point Q. All right, 3, -2 would be approximately right there. That will be point R. Okay, so point R at 3, -2. And 1, -1 would be in the center of that box right there, and that would be point S. All right, so now I'm going to graph that parallelogram. Okay, there's those two parallel sides right there. Excuse me. All right. And then I'm going to get my other two parallel sides. Right there they are. All right. And now I'm going to use my rule for 270-degree rotation. The rule for a 270-degree rotation is that XY changes to Y -X. That came from right here. That's our rule, our algebraic rule. Okay, and that's a Y right there. So I need the coordinates for point P prime. I need coordinates for point Q prime, for R prime, and for S prime. Okay, so the Y coordinate will become the X coordinate. So for P prime, 7, and the opposite of the X coordinate becomes the Y, so 7, -4. Okay, all right, for point Q prime, the opposite of the Y is -6, and the X coordinate 6 becomes the Y coordinate. Okay, all right, oops, did I do that one right? Oh, no, this one should be positive. That one should be negative. I'm sorry. The Y coordinate 6 becomes the X, and the opposite of the X becomes the Y. Okay, all right, let's go to R. The Y coordinate, -2, becomes the X coordinate, and the opposite of the X coordinate, which would be -3, becomes the Y coordinate. All right, so the Y coordinate of S, -1, will become the YX coordinate of S prime, and the opposite of that, X coordinate, -1, will become the Y coordinate for S prime. Now I simply plot those 4 points, we'll start with P prime. 7 is right here, -2, 4. That will be point P prime. Okay, so point P prime. All right, at 7, -4. 6, -6, so 6 and then down 2, 4, 6 will be point Q prime. All right, -2, -3 would be approximately right there. That will be point R prime. And then -1 would be in the center of that box, and that will be point S prime. And then I'm going to connect P prime to Q prime. Okay, Q prime to R prime to S prime. And then finally go back, and you will get your quadrilateral P prime, Q prime, R prime, S prime rotated 270 degrees. All right, you can rotate your paper, not 90, not 180, but 270 degrees, and it should look the same as what you had before, except for the namings of just get the primes and take them away and put them on the other, and you'd be okay. All right. Oops, and I think I did the wrong one. By the way, that was this one. So 90, 180, it should be the same thing. Is that right there, 270 degrees? So the original should be down here now where that one, new one is. Okay, all right. If you have questions, please give me a call, show up in a Google Meet, email me, whatever you need to do. Thank you. Have a good day. Bye.